Right now, Eugene, Springfield is called the home of the Ducks, the Simpsons, Tracktown USA, even Nike's birthplace. But what about the Silicon Shire? Well, that's a new nickname a local company has come up with for the area, hoping it leads to more check jobs. Web design and development company Concentric Sky is behind it, creating a new website called siliconshire.org.
It's great to have companies like Disney Interactive and Zynga here in town. I think both of those shops have more than 50 people now, and they're growing. I think a lot of people look at Eugene, the second largest city in Oregon, and wonder where the jobs are here. And if you take a few minutes to look at the Silicon Shire directory, I think it makes it apparent.
As for the term Shire, Bruckner says he was inspired by the book The Hobbit, comparing the setting there to Eugene Springfield's outdoor and natural naturist setting here.
Through some slides talking about badges, badger, and pathways.
The Open Skills Network is a young, scrappy, and very focused coalition of universities, employers, government agencies, and the military who are on a mission to create the foundation for a more diverse and equitable labor market.
So my name is Wayne Skipper, founder and CEO of Concentric Sky, a company that I founded 13 years ago. And we've grown over the last 13 years to be about 80 people here in Eugene, Oregon. And we think of ourselves as problem solvers, and we solve problems for some of the most prominent organizations in the world. We've built software for the World Bank, the United Nations, NASA, a host of organizations, over 300 products.
Around connecting Tin Can and Open Badges together. Open Badges is a specification that recognizes and verifies learning using graphical badges, actual image files that are given to people in recognition and in order to verify the fact that they've learned something or perhaps achieved something.
Analyzing and understanding the big data of human capital. Several months ago, the Department of Defense open sourced a specification for experiential data. That is the data of people doing, learning, working within connected environments. Back in December, we were invited to present work that we were doing in the gathering of simulation data.
So I'd like to talk to you today about xAPI's potential in games, gamification, augmented reality, and we'll dabble a little in simulation as well.
Now, Zynga is one of the companies you mentioned there. It is now one of the top social network gaming companies on the internet with games like Farmville and Cityville. You've probably got dozens of requests from your friends about. Meanwhile, Disney Interactive owns Playdom Studios in Eugene. They focus on internet games as well.
The way we learn is we learn inside the construct of a game, and I'm going to get into that a little bit more on the difference, but basically we learn inside the game. The integration I see with Experience API is that the three main things. First, that xAPI can show you the path to the meaningful choice.
From flight simulators and game engines at the annual ITSEC military training simulations conference. What we did is demonstrated the ability to draw data out of a flight simulator in a format that was interoperable with wearable data. That we were collecting biometric data at the same time via Android Wear. So we were able to gather biometric data, heart rate, movement among participants in the simulation.
And Open Badges has these three principles, these three processes. The first one is earning. So this is about the learner themselves earning badges, being accredited for something that they've done, some achievement that they've made. And the kind of philosophy behind it was that often in academic education, you get accredited for academic learning, but often people do a lot of learning outside of that academic experience. And so they should be able to earn accreditation for those types of learning experiences.
The way we learn is we learn inside the construct of a game. And I'm going to get into that a little bit more on the difference. But basically, we learn inside the game.
We got involved in badging in 2015 when we were approached by the MacArthur Foundation to create Open Badges.
Welcome to those in Second Life and on the web, to the third in a series of conversations hosted by the Institute for Network Culture at the University of Southern California and Global Kids. I am Connie Yowell, Director of Education at the John D. and Catherine T. MacArthur Foundation. Our topic today is Reflections on Philanthropy in Virtual Worlds. Let me introduce Jonathan Fanton. He is the president of the MacArthur Foundation. Prior to coming to the foundation in 1999, he was president of the New School for Social Research in New York City for 17 years. I'd also like to take this opportunity to thank Jonathan for his extraordinary and innovative leadership of the Foundation. It has been under Jonathan's leadership and guidance that the work in digital media and learning was launched and has grown. He has guided our exploration in virtual worlds and led a true integration of technology across the Foundation.
And the key takeaway is that a badge is not a digital sticker. A badge is actually a portable data object. And so what we've done is we've taken the image formats, PNG and SVG, and we are adding additional metadata into that image file.
Culture is the repository of meaning, and meaning is always changing.
And you can see that data there on the right of this diagram.
Ability to triangulate different forms of data to help you to identify patterns, trends, behaviors that otherwise might be less intuitive.
Any skills tags, alignment to standards. In K-12, you might have NGSS or Common Core.
But the ability to passively make the tracking of human performance and business performance a part of expectation of what it means to be a worker, to contribute to an organization.
Mind is more like a social reality of shared meanings and values, and that each individual grows up in cultures where they kind of imprint on, they engage mind.
And these are fields that we've created in Open Badges that give us the ability to do a lot of really interesting things with these portable credentials of the future.
We are by our very nature interpersonal and related to one another and engaged with one another. And the very possibilities for a lot of meaning, it comes out of our embodiment, but it also comes out of the fact that, we have cultural processes that sediment these things.
To be able to have technologies that provide that in a passive, behind-the-scenes, very integrated, job-embedded format that actually shows the real work, the real life of what people are doing. That's the special offering that xAPI brings to the table.
Could information in the environment be modulating which genes get turned on, which genes get turned off? Now, we know that from epigenetics, but could it be other kinds of information? Could it be physical forces, like mechanical forces, electromagnetic fields? Could other kinds of information be communicating with how these systems are reading and writing information into DNA?
We need to have subject matter experts help us define what communication means in a retail context or a pharma context, because the information just isn't there. It's not in the job posting because of the way job postings are created. It's not in a syllabus or a resume because of the way those documents are created. There's no application of machine learning that's going to answer what is communication, right? We have to define those things and, again, do it in a way that everybody knows how to work with it in a clean and open fashion. And in my mind, that is the work of the Open Skills Network. That is the work of Concentric Sky in several different verticals. And that is what we're actually making possible with our work in Badger.
The Radiance Dome project is a geodesic dome of 40 feet across, 28 feet tall, consisting of a number of edge-lit light guide panels. And each of those is thought of as a pixel in a fluid simulation. And we use various types of inputs to control the colors in response to different types of input. For example, the leap motion, which is a little hand controller device, audio, so just ambient sound, as well as things like dancing. So we've connected it to a Kinect so that you can actually control it by dancing and other types of movements. We're really pretty unlimited on the input side.
What's needed is physical rules calling upon nonlinear mathematics. To approach these mechanical phenomena, we looked at the theories of chaos, fractal distributions, and their relationships with traditional science. The Americans, Buckminster Fuller, an architect, and Kenneth Nelson, a sculptor, both worked on macroscopic structures and designed buildings and sculptures with common characteristics. The basic concept is that the forces applied are transmitted to all the elements of a structure composed of long articulated girders linked by pre-stressed elastic cables already under tension. Such structures are therefore multidirectional, stable in all directions, and independent of gravity. These forces stabilize the structure through their equilibrium. But most importantly, all the forces are subjected to all the structural elements, with the result that the slightest increase in tension on any one of the elements is transmitted to all the others, even those the furthest away.
I've done a couple of articles on architecture and see that architecture is about affording certain kinds of meaningful spaces for animal interaction, or human usually interactions, right? Affordances.
Transparent and is sort of a physical object based on the sound, based on the input. And it creates a dynamic space really unlike any other that I've encountered.
I would say that creativity is something that's often lost in the mix in business. A lot of business people don't understand that creativity is essential to innovation, and that without creativity, you really can't innovate at all. And so it's important to try to foster that creativity wherever you find it. Collaborative partnerships between businesses and arts groups are essential. Well, I would suggest to look at it as something more than just a potential marketing opportunity. It's an ability to benefit the entire community by sparking creativity in other individuals that are not necessarily directly related to you.
Also, it's a laboratory to begin to study this interplay of a system that's fundamentally open, that's exchanging matter, energy, and information with its environment.
See where you came from, but it looks different because it's all being colored. You're being colored. Everyone around you is being colored in this really fluidic and changing way.
The octopus is literally as close as you can be to the antipodes of human beings in both phylogeny and behavior. The octopuses are asocial. They don't live in communities, they don't participate in communities. They are curious, they are capable of solving extremely complicated puzzles, they learn a lot of things by themselves in the wild.
If we remove their shelter and give them other objects, how might they use that in creating a new shelter?
Octopus immediately starts putting this here, this there, okay, trying to rearrange the environment. And this manipulation of the environment is a fundamental component of the definition of intelligence.
Emergence is, I believe, multi-directional. Again, that depends on the application. To some of us, the loss of control is control. With nature, there is this diversity that happens.
And the boundary between what is inside and outside of the space is really blurred by the material that we use.
Can these nanomachines process information quantum mechanically? And if so, could nature have already built some of the first quantum computing systems in the context of living systems? I spent a sabbatical at the Santa Fe Institute thinking about biological networks and modeled this nanomachine as this algorithmic state machine going through a series of internal states, and modeled how knobs in the environment could couple to and modulate this movement along the DNA.
How can the lights inform the movement, and how can the movement inform the architecture?
You can pull in other inputs. So Kenyon being a dancer, or someone being a singer, or a musician, or whatever it might be. With software, you can take all of those inputs, and merge them together and then output into a new medium, which is, in this case, this three-dimensional surface.
Mind was not just in individuals. It was a shared thing. And then each individual engages the meaning possibilities of its culture and in its situation.
As part of getting a language to describe a strong coupling between the environment and these nano systems. So now if you plug that in and you calculate the information processing power of one of these little DNA nanomachines, you find out that, I'll just cut chase, this nanomotor is making 10 to the 11th computational steps for every base pair that it's reading. That's a lot of computation that this little nanomachine is doing to read one base pair. So the question is, why so much decision-making is required in its choosing its movement to those internal states and its translocation along the DNA? Could it be that there's just, because it's reading the DNA sequence, or could it be that there's other information in the environment that's modulating and talking to it that it has to decide between? And so there's a lot of information processing going on. Could it be that consciousness or the mind is also inherently coupled to these systems and helping them choose between their internal quantum states?
As the complexity of the organism and the complexity of the environment And the more complex the organism is, the more complex the environment is for it, because there's more things it can pick up on, affordances.
But in the case of complex systems, you have a nonlinear phenomenon where the output is discontinuous with the input. Elements synchronize. Once elements interact in such a way that they synchronize, or that the whole begins to oscillate, you have a totality that has qualitative differences from the sum of their parts. And usually the synchronization and the oscillation emerges in a discontinuous phase transition.
This idea of protocols that are emerging, right? These kind of layers that you can use to, historicize the information and the transactions so that you can agree on a language, let's say, seems to be an enabling constraint that is emerging from society to increase the level of collaboration between organizations and so on. So what do you think about that?
I like that a lot. Though that to me is sort of saying, all right, here's a new code that will enable the interface between two systems that previously were competitive to translate the requirements, the specifications, or whatever from one to the other. And I think nature does that all the time.
So I think the future of design is in that soft control, is in the ability to design highly controlled systems that enable the loss of control, and creativity is very much part of this.
For example, what we currently call chance or randomness, could that, and I'm venturing to say, that the missing ingredient is consciousness as part of that underlying fabric of reality that's helping to decide between quantum states.
That then new emergent functions occur. Mind is a level of possible meanings that occurs when we reach the level of social interactions with other people.
What's the intelligence of an organism, an artificial machine, or an information processing device? Here I estimate that by the information extracted by the machine or the organism from its environment on top, and on bottom is the information contained in the environment. So a more intelligent organism gets a higher ratio of the information in its environment it's able to extract. Now the question is, what is this information in the environment? And could it be a hierarchy of information, not just in the environment, but also what we might call a more generalized consciousness?
We have to tap into a different theory of change. And the one that you mentioned is morphic resonance, which says that any change that happens in one place creates a field of change, so that the same change happens in other places. And that means, so any act of kindness, any act of generosity, it creates a field of kindness, a field of generosity, which means that your individual choices in the most intimate circumstances, the most humble circumstances, have a bigger effect on the world than the force-based mentality could conceive of. And it also has a bearing on projects like Celo or some of the cryptocurrency, other.
Currency is a channel that facilitates flows of energy, stocks, information, correct? And so we use the word currency metaphorically to talk about channels of information, correct? But we also use it to talk about channels of energy, be it chemical energy or electrical energy, current, or biological, metabolic energy, correct? So I think currencies are forms of enabling constraints, right?
You know, all of these, I mean, whatever beautiful project you have, like sometimes part of the mind is like, but okay, but this is just such a tiny drop in the bucket. Yet by devoting to something that calls to your love and to your care and to your ideals, you're also instigating a morphic field, a field of change. And it could spread in ways that don't depend on how much marketing force you have behind it.
This is a standard epigenetic landscape that Conrad Waddington formulated, I don't know, 50s, 40s, I don't know. But imagine if you only thought in terms of energetic power relations. All people would think of is pushing the ball here to counteract gravity and try to get it over this hump. But if you look at the right-hand image, you realize that it's all these underlying constraints that are creating the landscape, that if you were able to adjust the constraints that produce the landscape, you would change the topology of the landscape and the system might go in the direction that you wanted it to.
We're all imagining a future where learner workers are empowered with an evolving understanding of their skills and their experience and the value of those skills and experiences in the marketplaces where they live.
So the suggestion that complex system has is you're better off trying to manage an ongoing complex system by focusing on the constraints that underpin or subtend the obvious surface phenomena than it is to try to change it through powers.
We're working collaboratively to pull together a set of open technology standards that effectively allow for the quantification of learning, building off micro-credentials, competency frameworks, learning pathways, and blockchains. These same technologies lay the groundwork for the broad application of machine learning and recommendation engines in service of student success.
To share with you this great work in this incredible pilot project with my great partner, Dignity Health, Global Education, an incredible company, to help nurses upskill and thrive in their careers. And I have a tremendous executive here with me who is going to show you just something fantastic. And Adam Kaplan. Adam, are you there?
Yes, thanks so much, Mark.
It's a compelling vision for the future of education, and I'd love to share it with you this year at South by Southwest.
This is all about empowering the individual. So it's about the learner to learn anywhere and from multiple sources, and the need for interoperability. We're doing it for the tech industry, as Mark mentioned, and we're excited to see how this can help our customers in every industry, including healthcare. What you'll see in the video we'll play shortly is the power of this LER technology and open standards to upskill, reskill, and enable nurses to take more control over their career paths and their growth. With our partner Badger and following LER and open badge standards, we were able to create credentials that are easily shareable and independently verifiable.
Richard Edwards, I'm Executive Director for Strategic Learning at Ball State University, as well as the instructor for a series of free open online courses from Turner Classic Movies. Using Badger, I had a very high engagement rate in my Hitchcock course, and I noticed several things. First, I noticed that a lot of students like to share their badges on social media. I had 6 badges in the Hitchcock course, and they were a collectible set that referenced all the different eras of Hitchcock as a filmmaker. And as you collected all of them, I think students felt very compelled to want to get all 6 so that they had no gaps in their collection.
And when I say something is meaningful, I'm doing this in a pragmatist sense. I'm going to say that the meaning of anything, whether it be an object or an event, and objects are just, as Dewey says, events with meaning. It's all an event ontology. Everything's in process. So to say that something's meaningful is to say that it calls forth in some way experience, either past, present, or future possible experiences. So meaning is relational. It's about how one thing, quality, or event relates to and evokes some other experience. It's cashed out experientially.
Another thing that's really important for me to bring up is you don't need to be an artist to make a great looking set of badges. There's a lot of ways to use free art on the internet to do it, or to just come up with a compelling idea. And I use the example of word art and MacGuffins to really create a powerful sense of how these badges could also represent different parts of my course material.
I identify as a lifelong learner. I think we all are lifelong learners, but I also do software development and a lot of deep thinking about how credentials can be used in the world and how people represent themselves using records of what they've accomplished and the trustworthy relationships they have with other people. We mentioned we're partners with Instructure, really glad to have that new partnership this year, but we've also done work with a whole bunch of other organizations that we really like working with, pushing the envelope on advances in education and building great software solutions for mobile devices, for the web, and then also enterprise level systems for large scale data analysis. The whole point of the application is to bring portable, verifiable credentials right to your fingertips. And one of the great places to make this possible is, within the Canvas Learning Management System.
It's available only to Badger Pro users, gives instructors and learners an easy-to-use view of their progress through a pathway right in their Canvas courses. In this video, we'll learn how to use the Badger Pathways LTI to install and use pathways in a Canvas course.
All agents have in common one fundamental thing, which is that they pursue goals. And so now the question is, are you only interested in the local sugar concentration and you have a memory of a couple of minutes back and a predictive capacity of a couple of minutes forward, and then you might be a bacterium? Or do you have a bigger cognitive light cone and you might have a memory going backwards and some predictive capacity going forwards, but you're never going to care about what happens in 3 months, 2 towns over. So you might be a dog if that's the case. Or you might be a human, which has a huge cognitive light cone, and you're actively working towards world peace and what the financial markets are going to do 100 years from now. You could have a huge cognitive light cone.
Instructors help learners in a Canvas course to visualize their learning journey and to encourage and motivate them to achieve the completion of the pathway.
So the spark that really started the project was the idea that we could take this very well-known shape, the geodesic dome, and combine it with this idea of the illuminated lucite panel. And we said, if we put these two things together, these two relatively simple things together, we can do something that's never been done before. It also gives us an opportunity to make a canvas upon which we can draw, to make a canvas upon which we can draw, to make a canvas upon which we can draw.
Now, here's the really important part. This bioelectric map is not a map of this two-headed creature. This bioelectric map is a map of this one-headed creature. So what we did was we rewrote the the stable bioelectrical pattern memory in this one-headed animal, and it stays one-headed with a normal gene expression. So here, anterior genes only in the head, not in the tail. And it sits there perfectly happy like this until it's injured. So a single planarian body is able to store at least 2 different representations, 2 different ideas of what a correct planarian looks like, and sit there and it's a latent memory. It doesn't do anything until you injure the animal. The same body, the same one-headed body can store 2 different representations. So at the very beginning, I told you that this collective intelligence works towards, it's a homeostatic loop that works towards a specific set point. And the question was, how do you store a set point for anatomy? This is it. You are literally looking at an example of how of how pattern memories are stored. They're stored as a stable bioelectrical state in tissue. And it's this in particular is kind of cool. It's a counterfactual memory because this is not a representation of what's happening now. It's a representation of what you're going to do in the future if you get injured.
My claim is that meaning arises from our bodily and interpersonal interactions with our environments.
We want to bring verifiable credentials into the workflow and the regular lives of the organizations we work with.
Trying to put all of these very diverse agents, for example, collective tissues navigating morphospace, together with conventional agents on the same scale, is that you can come up with a central invariant, which I have picked as the spatiotemporal size of the largest goal
you can pursue.
And living systems are fundamentally open systems. They exchange matter, energy, and information constantly with their environment.
I literally think that certain kinds of intelligence pervade the universe, from simple particles all the way up. It's pretty ubiquitous in nature, and including in the inorganic world.
We have different pinnacles of intelligence at different places.
We don't quite get how smart plants are.
In the molecular scale, we're really looking to understand whether there's a universal language to nature and what that language is, and then build a tool that I think and dream of it as the iPhone for nature. If nature had an iPhone, what would that iPhone look like?
Now we're finally able to have the body of data and the capabilities to take that seriously and to develop a completely new framework for how minds come into being in this world.
You're probably familiar with Lego, the popular Danish construction toy, and you have a bag of it in front of your faces. Lego do a thing called Lego Serious Play, which is a kind of consultancy thing for businesses and organizations.
I'm a big fan of Lego. We can make a Lego system, we can make a Lego set, but at the nanoscale. We can use DNA origami to make a Lego set so that children can learn nanotechnology just like it's sort of a Lego game. We also use the Xbox for, as a control interface for nanorobots. We're just submitting a paper about using brain-machine interfaces to control nanobots inside a living animal, depending on what you think. As designers, we're just, we say, let's build something and see if it works. That's our approach, jumping off a cliff approach.
And it's based on the idea that by building stuff with your hands, it's a different way of thinking and it's an interesting way of thinking about stuff. People seem to like it. I'll just say a little bit about the Lego Serious Play process. One of the key ideas is that through building with the hands, it's a process which is the same as thinking with the hands, because there's like more nerve endings in your hands than anywhere else in your body. Nerve endings means connections to your brain.
So what we have devised is a platform that allows for multimodal or creates multimodal simulations. And we can think of this as a way of helping us model human-computer interactions.
So there is actually a kind of meaningful thing where if you're building with the hands, well then you're also kind of thinking and making. And if you talk to artists and craftspeople, they'll say, yeah, that's definitely part of the process of thinking, not just part of the process of creating, but part of the process of thinking is that you kind of fiddle about, see what comes.
When we set up the hand motion control, which is based on a leap motion device, I can show one person, if you put your hand here and move your fingers around, the height of your hand gives you color, and as you wave your hand around, it draws on the dome surface. And people's creativity is just really sparked by that.
Yeah, I think it supports creativity really well because anything that you do, any expression can be kind of reflected and brought into this conversation within the space due to its interactivity, which is really, it's not something that you just pass by.
The models of meaning from philosophy and some from linguistics are not cutting it because they don't get down into the qualitative dimensions and the emotional dimensions and all of that. Another way to do this, which is my way, is to say there's linguistic meaning, there's what happens when it takes up into systems of symbols, but there's a vast continent of other meaning, embodied meaning that is, involves music, dance, architecture, ritual practice, things like that.
I think it's sort of really interesting and compelling to imagine what would be the game equivalent of something, when you glance at a game, well, maybe it's going to be a little longer than a glance, but really shouldn't be more than a minute or two of gameplay. So what can you do in a minute or two of gameplay that can still carry kind of rhetorical heft, right? And carry the same level of sort of rhetorical power that editorial cartooning does. What we're really trying to do is figure out how to map roles, kind of news roles, onto game mechanics to achieve rhetorical ends. And we're creating sort of an intelligent authoring tool, sort of an AI-assisted authoring tool that will allow newspaper editors who, they're not game designers, nor are they game implementers. They're like, even a short Flash game can take like a day or two to make. even if you're a pretty fast programmer. And a day or two to make is too long for these games. If you're going to make these sort of quick commentary games that have a short, kind of rhetorical fuse on them, you need to be able to make like dozens of them a day, right? In the same way that that an editorial cartoonist can kind of crank out editorial cartoons. Well, this is going to require, even for an experienced game developer, some kind of smart authoring tool that helps them map news roles and relationships onto game mechanics. But in order to build that tool, you have to have actually done the analysis to take the procedural rhetoric idea and really cash it out into kind of a detailed system, a detailed kind of meaning system for how specific kind of mechanics make meaning. And I think these short news games are perfect because they tend to use kind of relatively simple arcade mechanics. And so it makes me actually have hope that we can sort of exhaustively explore the space of relatively simple arcade mechanics and come up with kind of a formalization of procedural rhetoric for that space, which would then enable these news games.
Most of the meaning we engage, most of the meaning that goes on, most of the thought that goes on is not conscious and is not accessible by consciousness. Meaning operates within a vast, continuous, non-conscious or marginally conscious process of organism-environment transactions. And it's going to involve images, patterns, qualities, feelings, emotions.
I believe that in order for us to use the mathematical machinery of physics to come to terms with life in living systems, we have to expand this framework. And we have to expand this framework to include things like information and consciousness. And we need to be able to understand the interplay of how matter, energy, and information, and even consciousness talk to each other.
And we, of course, are a compound intelligence where our cells have little tiny light cones, and our organs do, and so do we, and possibly larger structures in which we participate. So this idea of a cognitive light cone is based around the goals that any particular system can follow. And so that allows you to start thinking about what an individual actually is. What are cells? Given that we're all collective intelligences, we're made of parts. We're basically a bunch of cells in a trench coat. How does the collectivity and the unification happen? What do we mean by one embryo? What are we counting? What is there one of? Well, what there's one of is alignment, not just physical alignment, although that's true too. Cells have to physically align with each other in planar polarity, but we are counting alignment of purpose. What we're saying is that under normal circumstances, all of these cells will work together to build exactly this thing. This whole blastoderm, all of them together have this one goal. And we know that because if we try to deviate, they will try to compensate. They are all together trying to get to this one goal. What you see is that the robustness of development is not just the property of a single embryo with its own genome, but actually a group phenomenon where a number of, in fact, the larger the group, the better, large collections of embryos are able to together solve the problem of morphogenesis better than individuals or small groups. And so in both cases, it's this really interesting dynamic of where biological control information comes from.
I came to realize as a designer, sort of 8 years ago, that nature can actually be a design medium through this new field called synthetic biology, which recognizes that biological structures have embodied computational frameworks that determine their architecture and their function. So I became really interested personally in trying to get new architectures to build themselves with sort of composed of biological tissues.
Howard Patti, who was a very well-known biologist in the 70s, he was one of the first to use the term enabling constraints. That is, conditions that facilitate the emergence or the appearance of those complex coherences that I was mentioning earlier, like synchrony, or like entrainment, or like coordination dynamics.
And the morphogenetic code as a sort of more layered enterprise. So it's not only genetics, but also epigenetics, which consists of bioelectricity, as we'll discuss in the episode. Can we start with one structure that is known to build something in the body, in this case, human trachea, but then can we, by giving it environmental inputs, can we get it to create a completely novel structure without touching the genome?
Is that life, mind, and consciousness are emergent phenomena that emerge when matter attains some critical degree of complexity. Then it starts to manifest self-awareness and consciousness. I believe that as we advance some of these new capabilities and ways of thinking, that we might find that the laws of physics are consistent with and provide new insights when we look at a new and perhaps ancient scientific paradigm where information, consciousness, and mind are something fundamental to the fabric of reality, even more fundamental than matter, energy, and space-time. And matter, energy, and space-time emerge from that underlying reality.
Because creativity is all about letting go and beginning again and beginning again and beginning again. And when you cannot let go, you cannot be creative, and you can't find novelty.